about sig figs real fast so that everyone is 100% clear. So going back to where you guys are, that doesn't work, does it? Going back to where you're on 30, how do you know how many sig figs to record on all of these? You look at the initial number, right? You look at the measurement provided. So these are all using the metric system, using the prefix system, where we go from centi to milli to nano to micro to wherever. So the entire metric system on that King Henry dive thing has one sig fig. So we just ignore it because it's not really affecting our measurements. So that's where we take those. But in a word problem, and I don't want to lie to you, I told you one way so that it makes your sig fig life a little easier. But we need to recognize that actually literally every single number in here is actually a measurement taken at some point in time. Maybe we didn't take it, but it is a measurement taken at some point in time. So let's look at the first one. When I'm reading, I see this number. How many sig figs? Shout it out, come on. 3, and then I see 18 grams per mole, which is 3 sig figs, and then 4 sig figs. So what's our final answer going to be recorded in? 3 sig figs. Okay, so 34A should be recorded to 3 sig figs. Okay, keep going. Talk to the person next to you on B, C, and D to decide how many sig figs should be recorded in B, C, and D, and then we'll check real fast. You can pull it up on your screen, which might be easier to see. All right, looking at B, how many sig figs here? How many? Loud and proud, guys. I need most people involved here, okay? There's 5 there, and then we see this one with 3, and then we see this one with 3, so who wins? 3 sig figs all the way. C, sig figs, 3, 2, 4, who wins? 2 sig figs. Last one? 2 and 3. So that's going to win as 2. So make sure when you approach these, you do think about everything as a measurement and everything is, all of those numbers will be helping control the sig figs. Okay, so go ahead and start approaching those if you've not, just so we know we're on the same page. And you will go back and do some more of this, but I want to give you a chance to check. So 1.75 seconds. Give me a thumbs up. 30A, 30B, 42,700 milliliters. C, can't tell if that's a decimal. Yes. Can't tell if that's a decimal with my scanned copy. 261 times 10 to the negative 4th millimeters, or is that a decimal right there? 2.61 times 10 to the negative 4th millimeters. Yes.
For the next one, number 4, you can also write it as with a decimal 0642 because it's still not
00642.
Yeah.
So 00. Yes. So that's correct, and that's correct. I just like to show you guys both of them in terms of scientific notation many times. Scientific notation is nice to do because you can see the sig figs right in the front. There's no like question as to how many sig figs are here. On E, you guys, I think you guys can probably read this. 8.25 times 10 to the 9th nanograms. F, 7.3 microliters per second. Are we okay? Heard of what? All right, so check out the math here. Went to liters first, and then microliters using 10 to the 6th per liter. That's our base. You could have gone directly from milli to micro. I just took a base kind of stop. And then minutes and seconds relationship, 1 and 60. G, 7.386 times 10 to the 4th milligrams per millimeter squared. That's the squared unit one. You distribute your squared out. H, 1.53 grams per centimeter cubed, and that liter or milliliter to centimeter cubed relationship 1 and 1 we should now know because we've used it a couple of times, especially with density. And then I, 6.00 times 10 to the 10th nanoseconds. right, so if you need some help with this, I will help you, but just give me a second because we're going to check 34. Okay? Some of us maybe have not gotten all the way through 34, but if you can write down your answer, you have a second to try those and then get the help you need. So in 34, A, we talked about this already, 3 sig fig, so it should be 350 dot. So that decimal holds on to the 0 and makes it a significant figure. So as you're processing that, do you think about how to round? Give me a thumbs up when I can move on. All right, B had density in it, which was a conversion factor. That was a distractor. You actually did not need it. So some of you guys already saw that and you're like, oh, it's just a distractor, I don't need it. So as you're processing from 0.2 grams, you make it to 1.71 kilojoules, which is 3 sig figs, which we talked about as a, these two conditions gave us the 3 sig fig kind of final answer. Thumbs up. Who's made it all the way through 34? Some of us. Okay, so let me hold off then for C and D for a second, okay? So, open up Kahoot. We're going to do a quick break from this because it can get monotonous to work on, review the entire class, okay? We're going to play a quick Kahoot, and then we'll do our projects, and then we'll come back. Just want to play this again. All right, and it's loading, considering loading. All right, so we're gonna make this fast and furious. If I'm gonna skip you, I'll skip you. That's just, it's not that I love you. It's just tough love. So get in there. 7, 9, 6, 5, 2, 2, 5. All right, that should be everybody. Here we go. This one's pretty simple, guys. I think you can make 100. Let's go. Properties that describe how a substance looks, feels, tastes, or not taste, state of matter. Moving in. Okay, moving on. Properties that describe how a substance reacts with another substance. You can have a quick, if you need it, you can have a quick chat with the person next to you, but I think you got it up here. Keep going. What does a chemical change result in? Read this one closely. All right, so I knew we'd have a breakdown between yellow and green here. All right, so I'm going to draw something and you tell me if this is a chemical or physical change. Okay, so here's water. It's like ice and it's all really close together. And then here's gaseous water. I rearranged the atoms, right? But did I actually chemically change water? Ice water, so solid, to gaseous water could be a rearrangement of atoms, but not a rearrangement in new bonds or new substances. So that's why I said read them carefully. Good job, 20 of us. All right. Which of the following is an example of a physical change? Somebody hit next. Please. Okay, let's do the orange juice. Right, okay, so you're going from like the solid form of orange to liquid form of orange. Physical change. All right, identify what's happening in the picture below as a chemical or physical change. It's a marshmallow roasting over a campfire. So in this particular one, it was talking about the marshmallow roasting. So the marshmallow roasting and the fire were both examples of chemical changes. So that one was not a both. Drying wet hair is an example of okay, so we're going from wet state to wet state. Liquid to, thank you. You got to think chemically, liquid to gas. That is an evaporation process. A statue damaged by acid rain is a chemical change. True or false? Alright, 28. Ooh, okay, so statues are made of like marble or calcium carbonate, which is what the same thing as chalk is made up of, and shells. Like, you know, they grind up like little aquatic organisms to make chalk for us. Organisms. It's not fun. Okay, anyway, acid rain reacts to it, which is eroding it and chemically reacting and making like noses and eyes kind of disappear from statues. Why is the below picture an example of a physical change? Probably the best answer. That's always the rule of thumb, right? Best answer. All right, 28. All right, so I can see this. This is definitely an option, but the most like creative way to say it, I think, would be this, which would be kind of more of a general phrase for physical changes. So that's why I chose that one. But I would totally give you credit here. No questions. Does the following represent a chemical or physical change? You gotta look closely. Ooh. Okay, so we see compound, yes? Yeah. Blue and red are bonded together, and then what do they do? Okay, so is this a physical change or is this a chemical change? Because you're breaking the bond that held them together, and now they're all separate entities. If you break a bond or you rearrange something to make a new substance, definitely a chemical change. Does the following represent a chemical or physical change? All right, we're getting a little bit better with identifying this. So again, we start with a compound. We end with a same compound, right? But this is probably a gas, and this is probably maybe solid or liquid, right? But it did not change its chemical composition. It just changed the way it looked. And now is it like a more condensed state of matter? Keep going. Does the following represent a chemical or physical change? I wonder what this is going to be. Those are orange. Orange. Sorry, tiny picture. No! Oh, getting worse. Okay, so back to me. Compound, did it change? Not chemically, right? Sorry, it did a physical change. It went from gas to maybe liquid. What happened to the gas, the orange gas? Stayed a gas, right? So either way, is it physical all the way change just for the red blue thing? Okay, here we go. Picture time. Got this one. All right, 28. Okay. I don't want to know who one person is. The one person, this broke a bond, bond broke, and then they rearranged to form new compounds. All the way chemical that forms new compounds. What type of change is happening? Okay. Where's the physical change? The wax melting. Where's the chemical change? The burning, the combustion of fuel. Okay. Most of you guys are like, yeah, for physical. That was both. Good job, 10 people critically thinking. All right. 2 more. All right, this is a weird question. Say it again, wait. kind of an interesting question. I did not make this computer up, just to be clear. Okay, I would go with all of these answers. All of these are correct. But yes, if you're just changing the size of the baby, just the size of the baby, physical. That's why this was physical. But there's a lot of stuff that goes on with that process, so I get it. When iron is exposed to water or vapor in the air, it rusts. Muy bien. Okay. Thank you. Just want to get a quick capture of your knowledge. And then here's what we're gonna do for projects, okay? So if you need your paper, your like poster format project, in just a moment you can grab it off the top of the laptop card. If you have it yourself, keep it. And if you need a digital format, go ahead and pull that up now. So what you're gonna look for in someone else's presentation, and remember this is a discussion, and you want to have an exciting discussion, because if you bore them to tears, they will give you a comment. So I'm only going to do one thing for now because we got about 20 minutes left in class. So either you want to split a paper with a partner, tear it in half, or have your own. Okay, go ahead and do that first. So split a paper in half or have your own. Title it Nano, and then put your name. All right, be quiet while I explain, okay? So presentation 1, you're gonna put friend's name, whoever, and I'll tell you how to put it up in just a second. Okay, so you put their name, and then you're gonna give them an engagement kind of thought. Okay, so if they were like horrible in their engagement and their like enthusiasm and their eye contact and just the excitement that they have to share with you, they get 0 points. If they were like pretty good and they could do better, they get 5 points. If they were amazing and awesome, they get 10 points. So literally all you're writing here is some number of points. And then you're going to give me a comment on their presentation. And it can be related to their verbal presentation, their visual presentation, or something else they shared. Okay, so we're going to try to hit 2 presenters. Cool? Write your name. You're going to write somebody else's name. You'll give them some number of points, and then you'll make a comment. Okay, you have to right now practice being enthusiastic with the person next to you. Go. No, 0, 5, and 10. 0, 5, and 10. That's it. All right, come back to me. 3, 2, 1. All right, so everybody make eye contact with me. All right, this is how you present. You look at every person that you're talking to, and you smile at them. And what they're going to do to you to ensure that you know that, I'm getting some attention from you, she's going to nod her head and kind of be like, oh, okay, yeah, great job. Like, you really just kind of keep that dialogue up, okay? So, if you are in the left-hand seat, get up and move to a live station. Goodbye. Get up, move to a live station. Bring your stuff, like bring your presentation stuff. And at this point, everybody should have become a natural partner. If you're at a lab station, you probably have a partner like at the same lab station with you. And if you're here, there's somebody that's kind of really close, okay? So I'm putting 6 minutes on the clock. That's 3 minutes per person. Go. I don't. I'll go. So I did nanotechnology, and basically what happens is there's do you have a partner?
I was like, we have an even number. Colin. The second partner should be sharing at this point. Second partner should be
I was like, hang on a second. What did I put on here?
Okay, so kind of do like a clockwise-ish rotation. No, that's clockwise-ish rotation. I'm new buddy, so I'm giving you like 5 minutes this time. So you guys please let me split off.
Jacob.
And go. Time off the clock.
Oh wait, ladies first. I didn't say anything wrong with bars. And there's like tons of benefits in it. Main thing is like when they put anything else in the car, it's all around the country. And so their main like what they do with the most is weight reduction in the vehicle, which in turn requires less fuel consumption, which means less greenhouse gas emissions, which means like no global warming, which is great. You can also put nano coatings on the car, and it's like you ever see those really vibrant paints on the car that's little nano coatings and nano varnish in the paint. Impact on daily life. We have less our carbon footprints. We have better tires, better car bodies, like damage resistant cars. In the future, probably pretty cool. The car in comparison has, along with the engine in the front of the car, has 4 engines in each tire. So, like, there are nano sensors on each tire. You drive it on uneven, and it's like there's different elevations in the tire. It all adjusts to like different ones, so it like reduces fuel. My big yeah, and that's makes it there's a comment gotta be on. I don't know why I went to I was just like, I gotta be extra. Hey, that was my, I was like, yeah. Really?
Yeah.
Oh my god. Yeah, I say greens and noodles and then funny pictures.
I like it.
Yep. All right, I'm sorry to cut you off, but time is dwindling. All right, and Beth will find a seat in like 10 seconds, please.